on the bench I have this Yamaha natural sound receiver. It's a model RX V870. The customer's complaint is that the sound level changes while it's playing, and we're going to have a look at it. Now, I've already had it playing for several hours and I've determined what the cause of the problem is here, which I'll show you if I can. Now, this was going to be quite difficult to demonstrate because in order to do this I have to have music playing, and I don't really want to violate any of YouTube's copyright policies, so I'm going to try and do this quickly. What I've determined is that we have some bad controls here, namely the bypass control here and the bass treble balance, etc. The controls need to be cleaned. Well, we'll turn on the sound here, and maybe you can hear it, maybe you can't. Hear the noise? Now, one channel is completely cutting out as I do this. Also, if I wiggle the bass control, etc., the left channel is cutting in and out. So we're going to take this thing apart. We're going to clean up the controls on it, and we'll inspect it and see if there's anything else that's obvious. But right now it looks like we've just got controls that need to be cleaned on this. It's going to be a pretty simple repair, but we'll give you a rundown of what this thing looks like, because these things were really built well. This is one of the better built receivers of its generation, and the thing weighs a ton. And you can generally tell a good amplifier from a cheap one just by the weight of it. And that's because this thing's got a big, heavy iron core transformer in it, which is something that the modern stuff just doesn't have. At least most of the stuff doesn't have. But this is a good unit from, I would say this is probably from the mid-80s. I'm gonna guess, but I would think this is probably mid 80s or so. It has the usual S-video inputs and outputs on the back and video switching. Your normal inputs, but it does not feature HDMI. It's a 5-channel receiver, so you've got your left and right. You can have 2 sets of speakers on it. You got your left and right. You got your center channel output. You can actually have 2 center channels or a single, and your rear. So it's basically it's a 4-channel amplifier. Left, right, center, and rear. It's a Dolby surround, not a Dolby digital. There's no optical input. Here you've got AV inputs and S-video inputs and a monitor out. So this would have been in the day of Super VHS, and High 8, but not DVD. Because of course the receivers that came out when DVDs were in their heyday, they had component inputs and outputs, because in order to pass the 480 progressive signal from a DVD player, you had to use component video. You didn't do it over S-video or composite. So this would date this thing. I don't even know if there's a date on the back there. There might even be a date code on the back of this thing. But I would say mid-80s. It's made in Japan, which is good. Draws 500 watts. That's your power consumption. But this thing weighs a ton. And we'll get the top off it here. Look at all the goodies that we've got in here. Starting over here, here's our main power transformer. It's got nice copper shielding on it here. And we've got our amplifiers in here. We're going to have one. Basically, it's going to have 2 stereo amplifiers, right? It's going to have one amplifier, which is going to be your. Actually, it's got a stereo amp and 3 mono amps is what it's got. Are discrete. Down here, it's got a STK 4141. I think that's like probably about a 40, 45, or 50 watt per channel amplifier. This would be for the 2 rear speakers. That would be your rear speaker amplifier for your surround sound. And these transistors over here, these are going to be your center channel. So they're probably, I'm not looking at the numbers on it, but I'm going to guess it's probably 75 or 90 watts for the center channel. It even tells you it's CT for your center channel, right? And then over here, you're going to have your right and your left channel on this side of the unit. Here's your right channel over here. It's got the little R, and the left channel is going to be over here. There's an L down on the board right over there. That's your left channel. So left channel, right channel, center channel, surround channel is on the IC down here. There's relays down here. Solder connections quite often go bad on these relays and will cause intermittent sound. Other than that, it's all discrete transistors. This is the amplifier board, obviously. Here's your standby relay to turn the power on and off. Separate standby transformer. This is for the remote control. So this always stays powered up so that you can hit the power button and the relay here will kick in and that'll apply power to the main transformer. So in standby, it's actually quite energy efficient. Over here we've got, this is our video switching board here. So this is the S video, this board here. Got to look at what I'm shooting. This board is your S video switching board, and next to it here is composite video switching. Notice that it's kind of a bit crooked. Audio inputs and outputs. This other board over here, this is the main audio processor. Volume control is right down here, so that'll make that easy to clean. It's got a little motor on it. Actually, here's the pots here, and this little motor here. When you hit the volume up and volume down button, it's a little electric motor that actually winds the control up and down. How cool is that? I love it like those ones. All the new stuff's electronic, right? It's all electronic switching. This is a good old linear control. Look at that. You know, it's got two double gang for your left, right, center, and rear channel, and then a single pot over here. So we got 5 controls stacked together. And as we continue to look down here, here's our tone board. Again, beautiful. You can get at these controls. You know, if you get in there with the cleaner, we're going to be able to get in there and clean this thing up real quick. And here's a couple of switches here that need to also be cleaned. But real nice design. Easy to work on. Now, some of the later Yamahas were just absolutely horrendous to work on. This is not one of them. This one here, we can remove the bottom. There's a sub-chassis that the circuit boards are in. Some of the more modern ones, the ones that were made in the 1990s, for example, they didn't use a sub-chassis that you could just remove the bottom. So you wanted to do any work on the bottom of the circuit board, you actually had to remove the heat sink, and you had to remove the board, and you had to lift the whole thing out, which was just a pain in the butt to work on some of those units. This one here is a breeze though. You pull out a few screws on the bottom, and the whole bottom panel is going to lift off this unit, which makes it a breeze to work on. Now you might wonder, why am I removing the bottom? Well, I want to inspect the relays, because a known issue on these amplifiers over the years was cold solder joints on the speaker protection relay. The more modern ones, it was a solid base, and you couldn't remove the base. It was one piece of stamped steel, and then the chassis was screwed in. You actually had to remove the chassis from the top to work on it. These ones here, easy access. So this is our relay connection here, and it actually doesn't look to be too bad. I'm just going to get in here with my needle nosers and just give the terminals here a little bit of a twist to see if they crack. Yeah, that one there might be. There's a bit of movement here. I guess it's okay. These ones look okay. Quite a common problem on these where you got cracks, especially around the bottom ones here on both sides. There's one on, you can't see one side here because of the metal covering it. But these are your outputs for your speakers, and quite often these would develop solder cracks, and that would cause you to lose your sound from one or both channels. Sometimes the relays go bad themselves, and you got to actually clean up the contacts inside the relay, which I might even do on this, just because I know the controls are bad, but I know that these particular relays over the years, we had contacts would get pitted inside them, and the symptom was you'd lose sound. It would, you'd be listening to it and one channel would cut out, and that's exactly what the symptom is on the. Of course, that's not the only relay on the board. That was for the left and right front channel. This one here is the center channel relay, and again, it looks fine. I don't see anything with these connections here that's cause for any concern. Here's the relay for the rear channel. Again, I don't see any issues with that, and we'll just inspect these pins here because these output ICs have a tendency to develop bad connections as well. So I'm just looking to see if any of those look like they may be in need of reheating. Well, here's a prime example. Remember I said I suspected that the main relay could be acting up? Listen to the sound. See, it's gone out completely. We have a relay problem on the left channel, so we're going to pull this relay out and polish up the connections, because that, as I suspected, I know that the controls are bad, but I suspected that that relay was probably a culprit too, because it's very common on these units that, especially this relay here, more so than the other ones, but these other relays also could be problematic too. Most people don't notice it so much on the center or rear channels, but they definitely notice it on the main channel when they're listening to music. But we'll pop the top off this relay, and maybe I'll take a look at the others as well, and we'll just go through there and give them a little polish up of the contacts and see if we can solve this problem. But definitely we have a relay problem on this now. It's pretty obvious, and I'll pull the relay out so we can show you the inside of it. So I'm going to use the good old solder sucker to take this stuff out, because I just don't feel like wasting that expensive solder wick. That stuff's really quite expensive, and you can only use it once, so this actually does the job if I can keep it from falling apart. Every time I reload it, half the time the tip blows off the end because it's so old. These solder suckers work good as long as you keep them clean. Got the relay unsoldered, and it should just lift out of the board here. There we go. Get the relay out. See, that does a pretty good job of removing the solder. Now I'm just going to take a screwdriver and we're going to open the relay up so we can see what goes on inside here. So here's the inside of our relay here, and what happens is these contacts, what makes the relay work is when the magnet energizes, it pulls. This is our coil. It pulls the switch closed like that. There's a little striker plate down here that it pulls up, and that flexes this little bar, which pushes the contacts forward like that to complete our circuit. And what happens is you get oxidization on these contacts here. So the best way to clean them out is like to use a nail file or something, like I did for the switch in the Betamax machine, and that's what I'm going to do here. I'm going to go get that nail file and we'll just sand those a bit. So this will probably work. I've got a pair of nail clippers that have got the little file on here, and that will probably do the job to clean oxidization off the contacts. So we'll just rough the contacts up a little bit here. Do the same for the other side. That'll take some of the oxidization off these contacts. It looks like that'll make a connection there. Snap the top cover back on. So the unit just popped back in the board like that. We'll grab our old ancient, actually this is not that ancient, my old ancient iron broke down. This is not that old an iron, it's just a cheap one. That is working. We'll just give that thing a tap here and see if it cuts in and out. Nope, solid now. Good, we've solved the problem with the relay contacts. Now I'm going to do the same for the other two relays and we'll clean the controls. So here's the second relay. This is the center channel relay. It's exactly the same relay as the last one. It's still a double pull single throw relay, just like the for the main speakers. It's just that they parallel the two of them together on this. So even when the contacts on this relay start to go bad, unless both of them actually go bad, you won't lose a channel. So the relay could be failing, but you'll never hear it in the sound until both of the contacts fail. Whereas on the other one side will fail and you'll lose one channel. These things are sometimes a bit of a bugger to open up, especially since this one they put some glue on it. So I gotta kind of get this glue off the seam here as it's holding the case together. And again, same layout inside. We'll do the same on this. We'll just scuff the contacts a bit. Okay, now we've cleaned all the relays. We're just going to clean the controls with contact cleaner. Get the neutral out. And I'm just going to spray it into the controls here and rotate them and the switches and stuff. So we'll start here with our bass and treble controls. So I can just access the control. There's a hole in the back of the control, so it makes it easier to get cleaner in there and clean the control up. Same with the treble control here. Well, there we go. Unit is fixed. So we'll shut that off, put this one back together, and get this one back to its owner. And there we have the Yamaha RX V870 back in service. The problem again on this one was relay contacts in the speaker relays, and the controls need to be cleaned. Hope you enjoyed this video. We'll catch you on the next one.